All right, let's jump right in. Welcome, everyone. Today, we are embarking on a really exciting journey into the awe-inspiring world of DIY electronics and single-board computers. Through this explainer, we're going to break down exactly how a tiny piece of silicon can completely transform your relationship with technology. Let's get to it. It's a profound question, right? I mean, we're talking about a device no larger than the credit card in your wallet. Yet, this tiny board has sold over 8 million units worldwide, and it's sparked a literal revolution in computing, education, and hardware tinkering. Oh, and fun fact, if you've ever wondered about the name, Raspberry is actually a nod to the classic fruit-named computer companies like Apple or Tangerine, and Pi stands for Python, which was its original intended programming language. But seriously, what can it actually do? Is it just a novelty toy, or is this a tool capable of running your entire digital life?
Okay, let's dive into Section 1, the mini computer revolution.
So, at its core, the Raspberry Pi gives you the raw basics of a fully functional computer. It was originally invented over in the UK to promote computer science education, but man, it has grown into an absolute powerhouse. It packs everything you need onto one board: a processor, RAM, graphics, integrated Wi-Fi and Bluetooth, and all your standard ports. And because it runs full Linux and IoT operating systems, it really is the perfect foundation for everything from learning your first lines of Python to launching complex Kickstarter campaigns.
Now for Section 2, Arduino versus Raspberry Pi. This is the classic dilemma beginners always face. Should I get an Arduino or a Raspberry Pi? Well, it essentially boils down to the muscle versus the brain. The Arduino is a microcontroller. It's the muscle. It doesn't have an operating system. You feed it a simple program, and it executes it flawlessly in real time, which is perfect for reading sensors or running motors. The Pi, on the other hand, is a microprocessor. It's the brain. It runs a full OS, natively surfs the web, handles multimedia, and easily juggles multiple complex tasks at the exact same time.
When we put the raw specs side by side, the difference is honestly staggering. Just look at that clock speed. The Arduino is humming along at 16 megahertz, while a Raspberry Pi 4 leaps all the way up to 1.5 gigahertz. That is a massive jump in sheer computing power. Notice the operating voltage too. Arduino typically operates at a sturdy 5 volts, while the Pi uses a more delicate 3.3 volt logic level. And with 40 GPIO pins compared to Arduino's 14, you are operating on a completely different scale of capability.
Which brings us to Section 3, inside Raspberry Pi 5. Take a look at the layout of the brand new Raspberry Pi 5. What makes this board historically significant is that it's the very first full-size Pi computer using silicon built entirely in-house. See that chip labeled RP1? That's the South Bridge. It handles all the I/O capabilities, delivering a massive step change in peripheral bandwidth. It's a real game changer. And these specs are genuinely jaw-dropping for a single board computer. We're talking a 2.4 gigahertz 64-bit quad-core CPU plus a Video Core V7 GPU that supports dual 4K displays at 60 frames per second. No way, right? But it's true. Plus, for the first time ever, it exposes a single-lane PCIe 2.0 interface for incredibly fast peripherals. Add all that up, and you're getting a massive 2 to 3 times increase in CPU performance over the previous generation. All right, let's move into Section 4, real-world Pi projects. Hardware is just metal and silicon until you give it a purpose, right? And getting started is remarkably accessible. People think it's complicated, but it's really just 3 simple steps. First, download the Raspberry Pi Imager to write the OS onto a microSD card. Pop that card into your Pi, connect it to your network and power, and boom! Within minutes, you can access your brand new computer directly through a web browser. So what should you actually do with it? Well, how about taking back your digital sovereignty? By installing NextCloud PI, you can replace big commercial cloud providers completely. You sync your contacts, calendars, photos, and files directly to a tiny device sitting right there in your own living room. You gain total digital privacy, and the best part is, you can get the whole shebang running in under 30 minutes. Or maybe you're just tired of fragmented smart home ecosystems. Running Home Assistant on your Pi creates this incredibly powerful, unified solution. Instead of buying a bunch of expensive, proprietary hubs that rely on distant internet servers, your Pi becomes the local brain of your house. It talks directly to your lights and thermostats, processing all your automations instantly, and most importantly, privately. Finally, let's look at Section 5, tinkering with GPIO pins. To actually interact with the physical world, we absolutely need to understand a crucial acronym, GPIO, which stands for general purpose input/output. These are those physical metal pins sitting right on the edge of the board. They act as digital inputs, like reading a button pressed or a temperature sensor, or as outputs, like turning on an LED or spinning a motor. This is the exact bridge between your software code and physical tinkering. Usually through a ribbon cable or some jumper wires, you connect these 40 tins to a solderless breadboard so you can prototype your electronics. But remember that crucial spec we noted earlier? These pins operate strictly at 3.3 volts. They are not 5 volts safe. In fact, if you accidentally send 5 volts into an input pin, you will fry the board instantly. Trust me on that one. Always use a level shifter when you're interfacing with 5-volt components. Now here's the roadmap for those 40 pins. And as you can see, they aren't all identical. While many are just simple on-off pins, others handle some really complex communication. Think of I2C kind of like a conference call, letting you connect multiple sensors using just 2 control pins. SPI acts more like a high-speed dedicated line for really fast device communication, and UART handles simple point-to-point serial data. This variety is exactly what allows highly advanced hardware to talk directly to the Pi's brain.
Which brings us to the core message of our explainer today. As your technical prowess grows, the Pi is able to grow with you. Whether you're just flashing your very first SD card to set up a media center, or you're writing custom Python scripts to pull SPI sensors over the GPIO pins, this single board scales effortlessly with your ambition. We've seen how it can replace cloud servers, automate your entire home, and power complex electronics. The raw potential is sitting right there on that tiny green circuit board. So my question to you is, now that you understand the tools, what are you going to build first? Thank you so much for joining me on this explainer. Keep learning, keep tinkering, and I'll catch you next time.